Hello, welcome to this video on convex lenses. We're going to recap refraction, talk about types of lenses, draw ray diagrams for convex lenses, and know how to describe the images produced by a convex lens. Refraction happens when light travels from one medium into another, for example air into glass. As the light reaches the boundary between the two mediums, it changes speed, and when the speed changes, so does the direction of the light. When the light moves from air into glass, it slows down and bends towards the normal. When the light moves from glass into air, it speeds up and bends away from the normal. There are two types of lens that you need to know about, convex and concave. They both refract light, but in different ways. Convex lenses converge light at a focal point, or a principal focus. Concave lenses diverge the light. To find the focal point, backtrack to where the diverged rays appear to have come from. There are key terms that you need to know about lenses. The lens axis is a line passing through the centre of the lens. The principal focus, this is the point where the parallel rays of light will converge. The focal length, this is the distance between the principal focus and the lens axis. There is a principal focus on both sides of the lens, and they will have the same focal length. The rays of light that converge at the principal focus of a convex lens are real rays. They are the rays of light that have been refracted by the lens as they move through it. The rays that meet at the principal focus of a concave lens are not real rays. The real rays are the ones that have been diverged away from each other. The rays that meet at the principal focus are called virtual rays. These virtual rays show where the light appears to have come from. Virtual rays are shown by using dotted lines. Images can be real or virtual. They can be upside down, inverted, or the right way up. They can be magnified, bigger than the object, or diminished, smaller than the object. An image that has been formed from real rays is called a real image. An image that is made from or partially made from virtual rays is called a virtual image. A mirror image is a virtual image as it's not made from real rays of light. The mirror image is just where the rays of light appear to come from. The real rays need arrows to show their direction, but virtual rays do not. A projected image is a real image, as it is made from real rays of light. For example, the lens in your eye projects a real image onto your retina. The image projected on your retina is also upside down. You need to be able to draw accurate ray diagrams for convex and concave lenses in an exam. Here we're going to do the convex lens. The diagram will need to be drawn on graph paper or squared paper, and you will need to use a pencil and ruler to draw your accurate diagram. If you do not use a pencil and ruler, you could lose marks in an exam. First, draw a line from the top of the object, here I've used an arrow, to the lens axis. This line should be parallel with the principal axis. Second, refract the line so that it goes through the principal focus. Third, draw a second line from the top of the object that goes through the point where the lens axis and the principal axis meet. Where the first and second rays meet, that is the top of your image. And you can see here I've filled that in with an arrow, the same as the object. This image is upside down, it is smaller than the object, and it is a real image because it is made from real rays of light. A couple of things to note about this diagram. The first ray does not go through the picture of the convex lens. This is because it's a picture. What's important is that it is parallel to the principal axis until it gets to the lens axis. The other thing that you might see in your exam is they might not use a picture of the convex lens, they might use the symbol for the convex lens. And this is a double-ended arrow with the arrows pointing outwards. As the object changes its distance from the lens axis, the image formed changes, but the rules for drawing the ray diagram remain largely the same. The principal axis is the axis that the principal focus is on. F is one focal length from the lens axis. 2F is twice the focal length from the lens axis. Let's start with an object beyond 2F. Draw the lines as previously mentioned. One parallel to the principal axis, refract it when it gets to the lens axis as though it's going through the principal focus on the second side of the lens. Draw another ray straight through the point where the lens axis and the principal axis meet and extend this line. Where the two rays meet, that's where your image is formed. This image is upside down, it's smaller, and it's a real image. For an object between 2F and F, follow the same procedure to draw the ray diagram, and the image that you get is inverted, magnified, and real. For an object to F, the rays do not meet, so no image can be formed. For an image between F and the lens, the refracted rays will not meet on the far side of the lens. To get them to meet, the rays must be extended backwards to where the rays appear to come from. These extended rays are virtual, and they form an upright, magnified, and virtual image. This is the image that you get when you're using a magnifying glass. Here we have a summary of the different images formed by a convex lens. When the object is beyond 2F, the image formed is upside down, smaller, and real. When the object is between 2F and F, the image is upside down, magnified, and real. When the object is at F, there is no image formed as the rays coming out are parallel. And when the object is between F and the lens axis, then we have a virtual image that is the right way up and is magnified. And that's the end of this video on convex lenses. Thank you for listening.